Okay, so we're gonna do day 2 of this. All right, so if you remember on the first day, we went through all those websites. You could go back and watch that for the basic stuff, but we're gonna practice this a little bit more now. All right, so turn to this page where it has number 3 on it. Okay, so whether you're doing area or volume, the first thing you need to do always is just graph what they give you, okay? So let's forget for a minute this is volume. Let's pretend this is area. We're going to start this the same way we would any other area problem. We're going to start by graphing y equals x, and we're going to do this as neatly as possible. This is all stuff you should be able to do without a calculator, but if you need a calculator, you can use that. The parabola is a little bit harder because it's not just like a parabola shifted up or down or right or left. It's a little bit more complicated. You could factor out that 2x, and that tells us that my 2 roots are at 0 and 1. So I know my parabola is going to look like this. You could also do a t-chart. I mean, these are all things we've seen before. So you could plug in 2 and you get 4. I know I'm going through this part fast, but that's because this is parts review. So you're going to graph that parabola as neatly as you can. And if you notice, this intersection point is not perfect. It's somewhere between 1 and 2. I'm not sure exactly what until I do a little bit more work. Okay, and that's going to be important because if you had to choose to do area with respect to x or y, which one would you choose? X. This one's totally set up to do with x. And if you notice in the volume it says perpendicular to the x-axis. So we are going to do this entire problem with respect to x. So I need to know that x value. So we could graph this, by the way. Something else that may have more meaning to you now that you've taken the quiz is just to solve and then set the 2 functions equal to each other. Whoops. X equals 2x squared minus 2x, comma x. Make sure you're practicing this stuff in the calculator. I know that's frustrating when you kind of get stuck on a quiz, but that just means that you probably haven't practiced this as much as you need to. All right, so 3/2 are 1 1/2. So that's a way you can do this without graphing. And I've shown that to y'all before, but again, it might have a little bit more meaning now. I need to know that x value. I don't need to know that y value because I am not doing this problem with respect to y. So if I was actually doing this as an area problem, let's kind of do this down here and then we'll get to the new stuff. I would integrate, and what would be my bounds? 0 and 1.5. And then which one of the 2 functions should I list first? The x, because the line is on top. It's the more positive function. And this would be how you do area. I'm bringing this up because when we start doing this volume, all right, instead of like a skinny little rectangle, what we're going to do is consider this to be S. All right, where you have basically a square that's protruding out of the paper. Okay, that's the 3-dimensional part. So what is the formula for area of a square again? Is the easy one. S squared. So if I wanted to find volume, I would do pretty much the same thing I would do for area. I would integrate from x1 to x2, but this S, okay, this slice or side of the square needs to be squared, right? Because the formula for 1 square is s squared. And the integration will just add all of that up. So you're going to type all this in your calculator. Okay, so we're going to go to integrate and open up an extra parenthesis, because remember the first parenthesis is to integrate, the second parenthesis is for squared. X minus 2x squared. Oops. I need a parenthesis here. Minus 2x. And what you now need to do is close the parenthesis on that second part, close the parenthesis on the body, do a squared, and then comma x, comma lower bound, which is 0, comma upper bound, and you could type it in as 1.5 or 3/2. If you type it in as the decimal, it's going to give you a decimal answer, which is totally fine, by the way. And when you press enter, if you get an error, it's probably because of parentheses or the stuff at the end. Make sure that what it looks like is that the whole thing on the inside is squared. Keep in mind the squared is not on the outside of the integral. It's on the inside of the integral, but to all of the things inside. Okay, and so that's how you get your answer, 1.0125. Now, once you've done squares, semicircles and equilateral triangles are just a really quick change. What's the new formula for a semicircle? And you can turn back the paper if you need to. I'm not looking for half pi r squared. Pi over 8 s squared, where s is the diameter of the semicircle. So again, it's like squared, but instead of s squared, it's pi over 8 s squared. If you try to do half pi r squared, you're going to do way more work than I'm going to do. So why do that? Now, if you look at these, the only the only difference is multiplying by pi over 8. So this volume is going to be pi over 8 times the exact same integral. So since I already know the answer to part A, what could I do there? Just multiply by pi over 8, right? Just go times pi, oops, I didn't hit the times hard enough. There we go. Times pi over 8. 0.398. You can retype all that in if you want. There's just no need. All right, we reminded ourselves of something we learned a long time ago in geometry. What is the formula for area of the equilateral triangle? Root 3 over 4 s squared. So again, it's just the same thing, except we have a root 3 over 4. And now, I mentioned this yesterday, but let me remind you, the reason I can put this to the front of the integral is because it's just a number. You can do that with a number. So I could retype that whole thing in if I wanted to, or in my calculator. Okay, I can just go up here and I could say, let me grab that number and let me go times root 3. Make sure you close the parenthesis there, divided by 4. 0.438. Okay, so if you can do a square, you can do a semicircle or equilateral triangle. They're not any harder than those. Rectangles are always going to be a little bit different though, so I'm even going to switch colors. Because what's the area of one rectangle with height 3? Yep, s times 3. So it's not s squared, right? It's just an s. So we can pull the 3 out to the front. The bounds aren't changing, but I'm not going to have a squared because it's not s squared. This is not a variation on a square, it's a rectangle. So if you were typing this in, again, you could type this in from beginning to end. Or what you could do, I'm going to go back up and grab this. And what do I not want in this? I don't want the squared, so just delete that part out. And then you could go into the very front and put a 3 in, or you could just do the answer and then multiply that by 3. It's up to you. But there you get your answer, 3.375. Okay, so I know I went through this example a lot quicker than the one from yesterday. But the whole idea is if you can do area, it's just a slight variation to do these volume cross-section problems. You've just about got to know these formulas over here, and you've got to be able to type it in your calculator, which really is just going to take practice. Okay, let's move on to the next example, which that says 9 there. That's just some bad editing on my part. Let's change that to 4. And sometimes on these problems, they give you this graph. You still got to be able to tell, though, which piece is what. So the curvy part is going to be y equals 2 radical x. And the horizontal line is this thing up here. Okay, so this says find area of R. Remember, with area, we get to choose. Do we want to choose with respect to x or y? Yes. That's a lot easier, right? So what would that area be? First of all, I would start with the bound x equals 0. And then it looks like this is kind of out. And then what would be my right bound? X equals 9. So if I'm in terms of x, I got to go 0 to 9, not 6. 6 is the y value. We're not using that when we're doing with respect to x. Then I need to do the more positive function, the top, which is 6, minus the bottom, which is 2 radical x dx. Okay, for time, I'm not going to go through typing this in the calculator. You're going to get 18, though. See how I labeled the graph? I think that makes it easier to figure out what goes in your integral. So if you're not labeling your graph, maybe that's something you want to pick up. All right, now to do the next part, this is the newer stuff. We have a region, base of a solid, yada, yada, yada. Okay, the cross sections are taken perpendicular to the y-axis. They're telling us we have to do this problem with respect to y. It would be so much easier if that y was an x, but it's not. The other thing they're telling us is that we have a rectangle whose height is 3 times the length. Okay, so the base would be s and the height would be 3s. So essentially we're going to do 3s squared. Okay, but I can't just do 3 this thing squared because of the whole with respect to y. So this is going to change how I label this graph up here, since I have to do with respect to y. I don't like this y equals. I actually want it to be x equals. So I need to change this into x equals. I don't want to do it, but I have to do it because the problem said you have to do this one with respect to y, this part B. So what would be the first thing you do to get x by itself here? Divide by 2. And that's going to be square root of x. So what would just x equal? Y over 2 squared, or I'm going to go ahead and make it y squared over 4. And that's the right function. I need to label the left function. It's the y-axis, but what's the equation of the left function? X equals... This is the vertical line, x equals 0. Okay, so these are the 2 functions I'm going to use for part B. Okay, let's think about our bounds. The bottom bound, we don't really care about x equals 0 anymore. We care about what y equals, which is also 0. But x equals 9, I don't care about that. I want to use y equals 6. Okay, so just to kind of, before we do part B, let me kind of show you what part A would look like if we did it with respect to y. I already know the answer should be 18. Instead of 0 to 9, you would do 0 to 6, and you would need to subtract these 2 functions in blue, and you'd need to start with the more positive one. And of course, you don't need minus 0. I just wrote this just to kind of compare. In part A, you could have done this either way, and you would have gotten the same answer. So if you knew in part B, you had to do part B with respect to y, you might have chosen, I'll go ahead and do part A with respect to y as well. It's a choice. It's a preference. With part B, though, we need to move on with this. So to do the volume, the 3 I can definitely move out. And I'm going to use 0 to 6 because those are my y boundaries. And then this whole y squared over 4 minus 0, that needs to be squared. And again, you don't have to have the minus 0. I'm putting that in just to clearly show what the left function is. And the directions say you don't have to input this, so that's actually it.